Hi, in this video we're going to review linear inequalities, and I'm going to be showing you how to use a calculator to help you expedite this process, check your work, or even solve some of these inequalities. All right, make sure you have a calculator with you, a graphing calculator. I'll be showing you mine here on the side. Go to the main menu, the home screen, and let's begin. So in this first example, we are given a linear inequality system. It is a system because we have at least two inequalities that we're going to be talking about finding the solution set. Now, if we wanted to graph these, we would be doing this by hand. We would be first graphing this first inequality. We have the slope mx plus b. You would graph it as a dotted line because there's no equal symbol underneath the greater than part. And then once you graph it, you have the dotted line, you're going to be shading above. Then we would go about the same equation over here, this inequality. We would solve for y, find the slope, find the y-intercept, and because it's less than, we're going to be shading below. Wherever these two shaded regions overlap, right, this common term or this common shaded region is known as the solution set. Now, as a faster way, I'm going to show you how to do this in the calculator. I want to know whether these 2 points are part of this overall shaded region that they both have in common. So to do that, I'm going to go to the home screen, press on calculate, and we're going to type in these inequalities with these points as well. Now these points represent an x and a y. All right, here we have x as 0 and y as 0. So I'm going to type in the inequality here. I'm going to type in 0 for y. Here, I'll type this in the first one. I'll type it in as is. I'll type in y is greater than. To find the inequality symbol, I go to control equals. And I can see that we have a greater than symbol. 2x minus 4. I want to type in the x value and the y value from the 0, 0. That's really what I'm looking for, okay? So instead of the x and the y, I'm going to plug in 0 for x and 0 for y. So let's do that. We have 0 for x, 0 greater than control equals 2 times x, which is also 0, minus 4. I have substituted x and y into this inequality. By pressing enter, the inequality or the calculator will tell me whether this is true or not. Here it is true, which means that 0, 0 is in the shaded region of the first inequality. Since we have a system, 0, 0 must be true for both inequalities. So I'm going to type in the second equation or the second inequality. 6x plus 3y is less than 9. But instead of the x and the y, I'm going to plug in 0 and 0. So I have 6 times x plus 3 times y should be less than 9. Control equals. I wanted to make it less than 9. And when I press enter, that says it's true, which means this point satisfies both inequalities. It's true for the first inequality, and it's also in the shaded region of the bottom inequality. Since it's in both inequalities, this is considered part of the solution set. So yes, 0, 0 is part of a solution set of the system. We can do the exact same thing and try plugging in -3 and -7 into this both inequalities again to see if that one also is true. So first we have 0, 0. Yes, it's part of our solution set. Let's try the next one. So we have y, which is -7. I want to use parentheses when I'm dealing with these substitutions. -7 should be greater than or equal to 2 times x, which is -3, minus 4. So I'm plugging in -7 for y and -3 for x into this first section up here at the top. Notice how it says true. So it is in the shaded region of the first inequality. Let's check it to see if it's in the shaded region of the second inequality. So I have 6 times x, which is -3, plus 3 times y, which is negative 7, less than 9. Control equals, is this less than 9? It's also true. So what does this mean? It means that both points A and B are in the double shaded region, or the shaded region that they both have in common. That would be our solution set. Now, if we were to graph this, right? If we were to actually graph these, this is what the function would look like. I'm going to bring this up to the front. Notice how there's two dotted lines. This darker gray area is the shaded region that they both have in common. 0, 0 is right here in the middle. It's in the shaded region. And negative 3, negative 7 is over here. Negative 1, 2, 3. Negative 7 is down here. That point is also in the double shaded region. So anything in this shaded, double shaded region is considered part of our solution set. So let's give another one a try. Let's get some practice in. Here we have, let me clear my computer a little bit, or my calculator. So here we have another system of inequalities. Why don't you give this a try? Are these points part of the system solution set? So plug in your x and your y into both, and to see if they're both true. If they're both true, then 2, 4 is part of our system, part of our solution set. And then we're going to try negative 3, 5, plug them into both inequalities. If they're both true, then they're also going to be part of our system. All right, give it a try. So let's do this together. The first one, y represents 4. So 4 should be greater than or equal to, maybe here, negative 1/2 x, which is 2. That is true. For the other system, the other inequality, 2 times x, which is 2, plus 4 times y, which is 4, should be less than 20. False. So while 2, 4 is in the shaded region of the first inequality, it is not for the second inequality. Since it does not satisfy both of them, A is not part of the solution set. It must be satisfied by both inequalities. Let's check the next one, negative 3 and 5. So we go to the first inequality. We have y, which is 5, greater than or equal to negative 1/2 times x, which is negative 3. That's true. Let's try to see if point B is also in the second one. So 2 times x, which is negative 3, plus 4 times y, which is 5, is less than 20. That one's true. So point B is true for both inequalities. So B is part of our system, and A was not, because it only satisfied one part of the inequalities. Again, if we were to graph this, we would want to graph this one with a solid line. We have our slope, and 0 is our y-intercept. Here I can solve for y, and notice how this one's going to be a dotted line, and we're shading below because it's less than. And this is what it would look like. Notice how 2, 4, 2, 4 is on the dotted line. And the dotted line means that it's not equal to the line, it's just less than the line. So 2, 4 is not true. But negative 3, 5 is right here in the solid shaded region, right? Whenever it lands on the line, if it's dotted, it is not considered part of a solution set. If it's solid line, it is considered part of the solution set. And anything in the middle will always be part of the solution set. Okay, let's try some word problems. Let's talk about how to write an inequality. So here we have a situation, right? The first thing you want to do is be able to read the word problem, identify your variables as your first step, and then the second step is identify the key word that represents the inequality you're going to use. So we're looking for two things here. So Nancy works at a Love at First Bite bakery where she decorates cakes and cupcakes. It takes her an average of 4 minutes to decorate a cupcake and 32 minutes to decorate a cake. Last week, Nancy spent no more than 224 minutes decorating cakes and cupcakes. Assume X represents the number of cupcakes and Y represents the number of cakes Nancy decorated. Okay, so we have a situation of cupcakes and cakes. We want to write an inequality that represents the possible combinations of cupcakes and cakes Nancy decorated. So let's first identify the variables. What does X represent? So if I go here, I'm going to shade a little bit. So X represents, I'm going to color this in one color. I'm going to do this one in red. X represents the number of cupcakes, okay? And then Y represents, I'll do this in blue. Y represents the number of cakes. Okay, so once you identify your variables, X is cupcakes and Y represents cakes, now I want to figure out what numbers are associated with X and Y. Right? If I look at the word problem in the top, it takes her an average of 4 minutes to decorate a cupcake. That's going to be in red. And it takes her 32 minutes to decorate a cake. That'll be in blue. I'm trying to associate what goes together. Okay, so I know so far that I have 4x and 32y, because 4 goes with cupcakes and 32 goes with cakes. Now, I'm looking for the possible combination, so I'm adding these two together to get no more than 224 minutes. This is the keyword I'm looking for, no more than 224. And I'll do this one we'll do it in yellow. I want to understand I want to identify what inequality symbol represents no more than. So I ask myself, can I spend more than 224 minutes? Like, let's say, can I spend 250 minutes baking? No, that's not possible in this scenario. So if it's not more, it's got to be less than 224. So I identify that it's a less than symbol. Okay, let's say it's going to be a less than. Now the question is, will it be less than or equal to? Can I spend 224 minutes in this scenario? And the answer is yes. She can spend 224 or anything less than that time frame. So we're going to be less than, and then we're also going to have the equal symbol attached in there. So we're looking for less than or equal to. Okay, so we put this together. We have 4x for the cupcakes plus 32y for the cake, and we want to spend less than or equal to 224. That's how I come with this inequality system. With this inequality. Identify the variable is the first part, what represents X, what represents Y, and then group the numbers that go with that one, and then identify, most importantly, the symbol. What symbol do we use for no more than? And no more than represents less than or equal to 224. All right, guys, hope this has helped. Please let me know if you have any questions. And as always, we'll talk to you later.